So if you're watching this video, you should pause the video and complete the warm-up and then play to check your answers. So let me go over the warm-up now. So the first one, graphing. So we know that adding 1 inside the absolute value is a shift left 1, and -3 outside the absolute value is down 3. So let me just get a coordinate plane here. So I'm going to do that. I'm going to go left 1 and down 3 and plot the vertex. And I see the -2 in the front, which means from that vertex, I'm going to go down 2 and to the right 1, and then down 2 and to the left 1. So from that point, down 2 and to the right 1, and down 2 and to the left 1, takes us right there. Okay, and then the vertex there is -1, -3. So that's our graph, which has been vertically stretched and has a negative orientation, and vertex at -1, -3. Number 2, write the equation for an absolute value graph with a vertex at 3, -7. Okay, well, if the vertex is 3, -7, that means it's been shifted 3 to the right and down 7. So we know that we need absolute value. 3 to the right would be x -3, and down 7 would be -7 on the outside of the absolute value. Number 3, so I'm supposed to find f of g of x, which means I'm going to put g of x into the f function. So g of x is going into the f function 2 places, for both of the x's. So f of g of x is equal to, I'm replacing x with x plus 3 and squaring it, plus 2 times x plus 3. And I'm going to simplify that. So when I square x plus 3 correctly, I get x squared plus 6x plus 9. And when I distribute the 2 to the x plus 3, I get plus 2x plus 6. So I'm going to combine like terms, x squared, 6x plus 2x is 8x, and 9 plus 6 is 15. So I have f of g of x equal to x squared plus 8x plus 15. Okay, so let's get started on the lesson. So first we're going to graph y equals the absolute value of 2x minus 8. So go ahead and put that in your notes. So if we had just an absolute value of x minus 8 and the 2 wasn't there, then we would already know how to graph that. We'd graph it the same way we've been doing the last couple of days. But the issue is we have a 2 as our coefficient for x, and we don't know how to graph that when we have something besides a 1 as the coefficient. So those translations that you were taught were based on the coefficient being a 1. So what we need to do first before we start graphing is we need to get this to have just a 1x inside the absolute value. So the only way that I'm going to do that is by factoring the 2 out. And when I factor out a 2, I'm left with x minus 4. And then I end my absolute value. Well, we know that we have a 2 inside an absolute value. So it doesn't really need to stay there because the absolute value of 2 is just 2. So I can pull that out and I just have the absolute value of x minus 4. Okay, so now this looks like something we are already able to graph. We know that this is just an absolute value graph that's shifted 4 to the right. So let's go ahead and make ourselves a coordinate plane and plot it. So 4 to the right, I'm going to plot that point, and I'm going to have a positive orientation with vertically stretched. So that means I'm going to go rise 2 and run 1, and rise 2 and run 1 the other direction. And there is my absolute value graph, and it has a vertex at 4, 0. Okay, so go ahead and try this next one. Copy it into your notes and try it, and you can pause the video if you want to try it first. So I'm going to factor out a 3. And I just showed this step to make sense of the problem, but you don't have to necessarily show me that step. You can just go ahead and factor the 3 out, which means we'd be left with x plus 5 inside the absolute value and then minus 2. So now it's in the form that I know how to graph. So make myself a coordinate plane. I know that plus 5 means left 5 and minus 2 means down 2. So negative 5 and negative 2 right there. And this is going to be vertically stretched with a positive orientation, so I'm rising 3 and running 1 in both directions. So rising 1, 2, 3, whoops, rising 1, 2, 3 and over 1, and 1, 2, 3 and over 1 again. Didn't mean for that 1 point to be there, so we'll just ignore that. But there is our absolute value graph with a vertex at negative 5, negative 2. Okay, and I can just get rid of that extra point there. Oops. All right, well, let's try that again. I guess I have to redo some of my graph because I just erased half of it. Oh my goodness. Okay, so we had negative 5, negative 2 was there. We're rising 3 and running 1, rising 3, running 1. There's our graph. Sorry about those technical difficulties. Negative 5, negative 2. There we go. Negative 5, negative 2 is the vertex. Okay, moving right along. So yesterday we took an equation and then created the graph from that equation. Here we're going to look at the opposite. So here we have a graph and we're going to figure out the corresponding equation. So I'll start by looking at the vertex, which is labeled there as 5, 2. And I'll think of this in terms of y equals the absolute value of something. And we'll think about the shifts the same way we have previously. So if this is to the right 5, we know that that means the absolute value would be x minus 5. And up 2, we know that plus 2 would be on the end. Now, I don't know just by looking here whether this graph has been vertically stretched or compressed, so I'm just going to leave that blank for a moment, the space in front of the absolute value. And now I'm going to count the rise and the run to figure out what the number should be in the front for the a value. So starting at the vertex here, I'm going to go from the vertex to one of these other points that are plotted. So rising 1 and running 2, which means the a value is 1/2. Okay. Also, I'm noticing it has a positive orientation, so I know that the 1/2 should be a positive 1/2 rather than a negative. So that is the equation of our graph. Okay, let's try another one. So this one, again, you want to get that plotted in your notebook. This one has a vertex at negative 1, 8. And some of these other points here we'll use to count the rise and the run. So first we'll start with the equation, leaving a little bit of space for the a. But I'm going to see that negative 1 is the vertex, the x part of the vertex, which means left 1, which means x plus 1, and up 8 plus 8 on the end. I'll put the a in the front. Okay. But to fill in the a, I'm going to figure out what the rise and the run are. So going down 3 and over 1 in both directions. So negative 3 is the a value. Okay, just double check then when you write your equation, just make sure it seems correct, it matches the graph. This does have a negative orientation pointing down, so I should have a negative value. Sometimes when you count the slope, you're just counting the 3 and the 1 and you're not really thinking about the fact that it's negative. So just to double check that, the orientation should match with the sign. So negative should have a negative orientation and positive should have a positive orientation. So I'm now sure that this is the correct equation. Okay, this one. So now I'm given the shifts, but I'm also given another point that the graph goes through. Notice I don't have a graph here to do the problem like we did the last one. In other words, I'm not counting the rise and the run. This is algebra. So, you know, in algebra, we are going to solve things using an algebraic approach mostly. So I don't want you to just graph this and do the problem the way we did the last few. Instead, I do want to see an algebraic approach. So let's talk about that algebraic approach. So the equation that I gave you the other day in class for an absolute value graph, the general equation looks like that. Okay, well, just reading the problem, I know that translated left and down 3, I know what the h and k should be to make those translations happen. So I don't know a, and I don't know y, and I don't know x, but I do know that to make it shift left 2, we have to add 2. So I'm going to go ahead and fill in that -2 value for h. X minus -2 means x plus 2. And then fill in the -3 or the -3 for the downshift. So the k value is -3 for the vertex. So I can fill that much in. And now from here, we're going to simply just use this point. And remember, points are x first, y second. And I'll substitute in the values for x and for y into my equation. So I'm going to go ahead and substitute -11 where the y is. I don't know a, but I do know that x is 2. So 2 plus 2. I'm going to take the absolute value of that in just a moment, and then -3 is on the end. So I'm going to solve this equation for a. So 2 plus 2 is 4. So I'm going to solve for a in a moment here. Well, the absolute value of 4 is 4, and 4 times a is 4a. So I'll just rewrite it because we usually put the coefficient first. Now I'll solve for a by adding 3 to both sides. And when I add 3 to -11, I get -8. And dividing both sides by 4 gives me a, which is -2. So now that we have the excuse me, the a value, now we can write the equation of the absolute value. So I'm coming back here to where we had everything filled in except for the x, y, and a, and we're going to go ahead and substitute in the a. So y equals -2 times the absolute value of x plus 2 minus 3. And that's the equation of our absolute value graph. Okay, we'll try one more here. So this one, go ahead and copy that into your notebook. So this time we have translate right 4 and up 6, and it's going through that point -4, 8. So I'd like you to pause the video and try this and then play to check your answer. So if you're checking your answer now, let's set up the problem. A goes in the front. X, right 4 would be -4, absolute value. Up 6 would be +6. Substituting the coordinate point, 8 is the y, and -4 is the x. The absolute value of -4 minus 4 is -8. The absolute value of -8 is 8, and that's times a, so that's 8a. And now I'm going to solve for a. So subtracting 6 from both sides, 8a is equal to 2. Dividing both sides by 8, a equals 2/8, which will simplify to 1/4. So our equation, again, we'll come back up here to where we started and just substitute in 1/4 for a. Y equals 1/4 times the absolute value of x minus 4 plus 6. And that is the equation for our absolute value graph. Now in class, I did ask students just to kind of check your memory here about what we've learned the last couple of days. Think about this question, 1/4, what does that mean in terms of the graph? Has it been vertically stretched, vertically compressed, or neither? So think about that. The answer is it's been vertically compressed. I know that because 1/4 is smaller than 1. Therefore, the graph has been vertically compressed. So if we were to look at this graph, we didn't have a graph, but if we looked at it, we would see the V, the absolute value V, would be open wider, because when we vertically compress, we're pressing down, the absolute value graph opens wider. Okay.